I'm going to talk about building a data stack in half an hour. So this is going to be like 5 minutes of me hammering through a whole bunch of slides and me attempting to do this live. So we'll see how that goes. I've done this before, but I got an hour to do it. I'll see if I can do it in 30 minutes. Okay, so a little bit of background. So I am one of the co-founders of Mode. Mode builds products for data scientists and data analysts. And as a part of that, we work with a bunch of companies that are trying to build out their data stack. So they're building their data teams that want to be able to distribute analysis to their stakeholders. And so there's obviously a prerequisite to that is building out a data stack. And so we see a lot of different things that companies build. So the first part of this is I want to share kind of what that modern stack looks like. What is it that a lot of companies are now building when they think about building their data stack from the ground up? What does that look like? It typically looks something like this. So here's a really basic diagram of what that is. You've got a bunch of data sources on the left. Everything feeds into a data warehouse, and then some sort of analytics platform on the right. And so I want to walk through kind of each one of these pieces and the types of things that we see, the things we encourage people to use, and then again, I'll actually run through setting these different things up. So the first part is that central part, which is thinking about a data warehouse. Obviously, that's a core part of what you need to do. You need to be able to have a place to put all of your data. So what do you do there? How do you think about like which data warehouse you choose? There's a bunch of different options out there. Different things that we think are really important to consider. First of all, you want it to be something that's really easy to set up and maintain. So especially when you're starting to build this from Go, something that's complicated often isn't worth it. You want something that you can actually get up and running quickly. And so things like Hadoop or sort of the big data systems often ends up with stuff like this, where it's actually much more difficult to set up than you may initially think. And so we typically don't encourage folks to set those up, especially if that's where you're beginning. Second, we encourage people to use plain SQL. That if you look at like the popularity of SQL compared to a bunch of other stuff that you could do to query databases, if you were to put like Spark stuff up there too, you'd kind of see the same trends. That SQL is still really popular. And so if you're wanting to access your data, SQL is the primary way to do it. It's what most people are going to know. We would encourage folks to use something that's very SQL forward. And finally, the ecosystem around this really matters. When you're setting up a database, it's not just the database that you're using. This is kind of the hub of everything else that you're using. It's the hub of where the data gets fed into. It's the hub of the applications that sit on top. And you want to have something with a really robust ecosystem so that you can use all these other tools and the ecosystem when you're actually building this out. So for this demo, I'm going to use Redshift. I'm sure a lot of you are familiar with it. Why do we choose Redshift for this? First of all, it's super simple to set up. I'll show that in just a moment. Second, it's based off of Postgres, so it's pretty straightforward. It's gone. It's based off of Postgres. Anyway, I'll see if this goes. Nope. Which is like a standard way of standard sort of form of SQL that most people know. Okay, so Postgres, it's based off of Postgres. Also, Redshift has a really rich partner ecosystem, so there's a lot of different tools out there you can use with it, a lot of things you can use in combination with it. Other options that we often see folks use, we see a lot of Snowflake these days, also a lot of BigQuery. These are kind of the three main things that we see people evaluate when they're thinking about databases. The second part you have to do is actually collect data. So there's kind of three major categories of the data you typically want to feed in. The first is like web traffic data or sort of generalized event streams. For this, we often encourage folks to use a tool like Segment. So Segment is a web tracking system. You basically plug it in on your site. It works as this kind of routing layer. You can kind of see how it works here. You track it up a bunch of different places. It feeds into Segment, and Segment writes it to a bunch of different tools. One of those tools, if you see that little kind of icon on the far right, is Redshift. So it's really easy to set up event tracking and write it directly to Redshift. It's also super simple. You'll see this in a minute. It's easy to set up. You just like add these little tracking logs, and that's all you got to do. And all like the APIs and stuff are really built out behind there. Other options here are things like Snowplow and Google Analytics, fitting the theme of like snow stuff up top and Google tools down the bottom. So these are also both event tracking systems. Google Analytics lets you write stuff really easily to BigQuery if that's what you're using as well. The other categories of things are like application databases or system databases. Say you have databases in a Postgres database, MySQL, things like that. You want to write that in your warehouse, or you have databases or data in SaaS applications. Say you're using Salesforce or Intercom or Marketo, things like those sorts of places. You might want to write those places into your centralized warehouse as well. There are some tools that are really good for that. One of the general philosophies we like to adhere to is to the ELT over the ETL. It's simply basically pull the data out, write it into your warehouse as it is, and do transformations later. This is something that's like a little bit controversial, though this seems to be the way the industry is mostly going, not doing a bunch of complicated transformations in the process of actually writing the data in the warehouse. So for the demo, I'll use Stitch for this. There are some other tools out there that are really work really well as well, but Stitch makes this really simple. Connecting things just requires you to fill out some basic forms, so it doesn't actually take any work. You can have data flowing in your warehouse right away. Similarly, if this is how you can write data from your Postgres database or any other application database into a warehouse like Redshift, all you got to do is fill out these forms and you're good to go. Some of these other options, so Fivetran is popular. There's also a tool called ETLEAP or ETLEAP. I'm not actually sure how they pronounce it. But these are options as well that are kind of just as easy to set up. Third step is cleaning and modeling data. So there's actually kind of this intermediate bit that I left out of this diagram. That when you actually do this, one of the things you might want to do is actually transform the data in the warehouse. So once you have raw data writing in from Salesforce, you might actually clean it up and transform it. And so there's some ways we think about when you want to be able to do that. One, it's good to have that be written in plain SQL. A lot of transformations now are written in sort of data engineering languages, primarily Python. We very much encourage folks to do that in SQL. The reason for that is because a lot of your analysts are the folks who are going to ultimately be writing these pipelines. And this is a blog post from Jeff at Stitch Fix, very much encouraging folks to say, hey, analysts should be actually the people writing those pipelines, not engineers, and analysts are the ones who know SQL. Second, and I think this is a really important point, that your transformation layer should be agnostic to the downstream applications. You don't want to have a transformation layer that's designed for one application or another. It's good to have something that any downstream application can use. The reason for that is, while this may be your initial stack, this is where you end up going. And this is actually what you're building on top of. You have things like ML pipelines and other marketing automation platforms. You have customer-facing applications. There's a whole bunch of things that you actually want to use that data for. And if your transformation layer only talks to one of them, then you end up having to replicate that transformation over and over again. For the demo, we're going to use DBT. DBT is an open source bit of technology that does this really well. There are some other options. Dataform, who some folks are here downstairs, as well as Airflow. You can also do this as well. Airflow also works as a little bit more of an orchestration and scheduling engine, but you can do some of these transformations in Airflow as well. The fourth thing you want to do is actually analyze and share your results. The point of getting all this data in one place and centralizing it isn't just to have it there. It's also to be able to do work on top of it, to be able to do analysis with it. So things to consider for that is, one, you want something that you can deliver results really, really quickly. This is really the core value of what a lot of analysts do. So this is from a Harvard Business Review article talking about the value that analysts really bring, and speed is the value that analysts really bring to your company. That's the highest virtue, as this says, that they have. And so you want a tool that really enables people to do that quickly. That if it's something that really slows them down, they can't answer questions quickly, then you're actually putting a lot of things in their way. Also, if you kind of over-plan where those things go, they typically don't work out. That one of the easiest ways to ruin sort of analytics initiatives or data science initiatives is to develop this really long roadmap for where you want it to be in 9 months, rather than kind of slowly iterating your way there and seeing what works and what you learn from it and changing it as you go. These kind of over-planned initiatives typically are things that you see kind of die halfway through because the data doesn't actually tell you what you thought it was going to at the beginning. Second thing, and a theme here is also you want this to be able to use plain SQL. That a lot of the folks that are going to be using this, whether or not they're engineers, product managers, or analysts, are going to be knowing how to write SQL. You want your analytics tools to be able to speak SQL as well, so they're accessible to a lot of people at your company. And so this also, it's the most popular thing among analysts and data scientists, even folks who would consider sort of the capital D data scientists. SQL appears much more frequently on Glassdoor ratings than these other things. So if you want an accessible tool, SQL first is typically a good way to go. And finally, you want something that's really easy to share. That there was this really great talk by David Robinson, who was the chief data scientist at DataCamp, about the unreasonable effectiveness of public work. And the idea here was, basically, your work is no good unless it's shared with other people. He was talking about this in the public domain, but he had this great slide, which was essentially the way he thinks about stuff is, okay, you kind of progress along the value of your work, but in reality, nothing is valuable if it's not shared, and everything is way, way more valuable as shared. And so you want some way to really easily share this work, because that's where all of the value of this actually is going to come, and given that the point of building this entire data stack is to get to this end, you want to help people do that as quickly as possible. So this is something Mode does. So I'm going to use Mode for this example. Mode does this because it's very much a SQL first interface. You have all kind of the charting and stuff you want, and it's also really easy to share. There are other options for this as well. So these are a couple kind of open source tools that you can use as well for this. They're also free. So you can use these sorts of tools too if you want to be able to quickly distribute this kind of work. So what comes next? This is what I'm not actually going to get into when I show this, but the next sort of things you would want to do are thinking about ingesting more data sources. How do you like ingest more event streams? How do you ingest custom data sources? There's a lot of great tools out there for this that you can already build on top of this ecosystem. So things like Kinesis Firehose, which is provided at Amazon, works really well for this. It makes it really easy to collect data from a bunch of different sources to be able to scale this stack out. You may also want to actually scale this up. Once you start to have a lot more data, you're going to need to be able to scale it up. Redshift can do this really well. There's like with a click of a button, you can resize the cluster. You can make it work with much larger data. That's going to cost more, which is a downside. But Amazon also has other paths here of things like Athena, which lets you work with data directly on top of S3 and scales up to something very, very large. So there's options to take this stack and be able to make it something that's scalable kind of to the size that like Fortune 500 companies would need. Another thing is thinking about data governance, like how do you lock down who can control what, who can see what. There's a lot of different solutions for this. This is something where you kind of get into like the IT world of analytics and data science. I'm not going to get into this much, but this is typically one of the places where people start to think about where they need to go once they're actually taking this stack a little bit further. With that, I'm actually going to walk through a demo of doing all of this in like 15 minutes maybe. We'll see how it goes. How that's going to work. So I'm going to set all this stuff up. The way this is going to work is first I'm going to set up Redshift. One of the downsides of this is there is a little bit of like lag time. If you set something up, it has to like spin up machines somewhere in Virginia or wherever. So you have to wait a few minutes for some of these things. So I'm going to like jump around a little bit. But we'll set up Redshift, set up Segment, set up Stitch to be able to write data to Redshift, and set up Segment to write data to Redshift. Then I'll connect Mode so we can actually query that data live, and then we'll set up dbt if we want to be able to do those transformations. So for this, I do have a few things already existing. I have an AWS account because you don't want to watch me fill out the AWS forms. That's like asking you a bunch of stuff about what company you work for and things like that. It's super boring. I have an application database and like a little web application that's pretty basic. That I can show you, and I already have Intercom integrated into it, so you can see how this works with a third-party data source. The other stuff, though, I'm going to set up Redshift from scratch, Segment from scratch, Stitch, Mode, and dbt all from scratch. So let's see if we can do this without this whole thing going crazy. All right. Let's see. Oh, geez. Get out of here. Get out of here. Get out of. All right. So this is the stuff. This is the stuff on the left that we're going to do. So here's what I've got. So this is my like fake company website. It's a video conferencing app. So it's like this super exciting web page. So this is what we're gonna start using to set up. And it's got a little like intercom widget down here somewhere. Should be once it loads. So it's a thing that actually is like a fully functioning website. So the first thing I want to do is set up Redshift. So here is in the AWS console. All I've got to do this is just click on Redshift, wait for the internet. Yeah. So they have this quick launch a new cluster. You do that. You can define some stuff. I've got some stuff here that I actually want to use for setting this up so that I know what the name is. We'll call it that. Call it that. We'll give it this very exciting password. And that's really all you got to do. So then you click launch, and now it's starting to do a few things. It's going to take a few minutes, and so you can see that it's creating this cluster. So that's all it takes. So the first part of this is simply setting up Redshift. It's like filling out a few basic forms, and you're good to go. The next thing I want to do, though, say I want to start writing data from like my website to this database. So I want to start recording events about when people are viewing pages and writing that to my database. So right now I'm not doing that. There's nothing here that's connected this website to that database. I guess I could make this a little bigger. So the way I can do that is through Segment. So like I said, like this shows, you can like integrate a bunch of stuff, write it all to different places, super easy. So I will actually sign up for a Segment account, maybe, if the button works. Ooh. Let's try a new tab. All right. Sign up for Segment. We'll get this email address. That's all of my stuff. Benn, email address, and this password. Sure. Fake. Sure. It's very small. I'll be the CEO. An agency, why not? All right. So then I have to verify an email address, which I can go over here. Let's go Gmail. Type in my password again. All right, so that's all it takes to sign up for Segment. You'll see the first thing that it tells you to do is connect some sources. And so what I want to actually do is connect a source from my website to write it to this database. So all I got to do is click Add Source, say from a website. We'll call it 10can. I think that's what it was called. And now, if I go to Sources, I can click here, and it will give me this little snippet of code. So this little snippet is all you got to add anything to your website to be able to track it. So this will start recording a bunch of different events about the people that are coming to your site, the pages they view, some like metadata about them, the users, things like the IP address, things like the browsers they're using, all those sorts of things that can be super valuable for analytics. So we'll do that. So there's all my passwords to fake stuff. So this is this application that's running that website. All I got to do is hop over to this thing, just add this one little snippet here. Oops. And so if I save that and now deploy it, you could all judge me for my console colors. Segment. And this. So now this is going to deploy to the website. As soon as this is up and running, what's going to happen is, just with that, Segment's going to start recording that data. I'm going to start being able to track every time somebody comes to this page, they're going to be able to see, like, again, all this information about them that can be useful for me to better understand what they're doing, and if I want to better understand those users and things like that. I now have all of that data already writing into a database. So as this deploys, the other thing I need to do on the Segment side, if my Redshift database is set up, which we can check, the other thing I need to do is connect Redshift to Segment, which will allow it sort of, that's the first half of the pipe. Then the other half of the pipe is writing things from Segment, or from Segment into Redshift. So this thing is now set up. So I can click on this, and now I have all this information about this database. You can see here's like the host and things like that. And so I want to actually copy this, stick this into here, because this thing gets generated for the first time when you write it. I don't want that. All right, and so now I want to connect this database to Segment. So those events will start getting written from Segment into that database. So if I go back here, that's not what I want. So if I go to Destinations, now I can add a destination. Redshift. And you'll see all I have to do is fill out some of these credentials. So that was the host I had. Database is DC demo. And then this password. All right, so that's now connected. So if I go back over here and go to these connections, you will see that now I have these two things connected, and all I need to do now is actually like turn them on. And I can do that. So hopping into the database, selecting the syncs to sources to sync, which I think I have to go here. Check this, save it. So now everything is all connected. So these things are, you can see there's data flowing from my website into Redshift. So in like 5 minutes, you can get a database set up. You can get actually data flowing into that database live from your database. Now, I want to see if this actually is working. I can go over to the source, click on this. Segment has this nifty little debugger tool. And now, if I refresh this page, if this thing is actually like, it takes some time for like CDNs or something to update, you can see that page view came from here. And I can actually look at a bunch of information about that page view. So there's like the IP address, the browser that I came from, which is this Firefox thing. So all that stuff. So everything here now, all of this data is actually getting written into Redshift. So if I want to start querying that, understanding how people are actually using my data or using my website, I can now do that. So the next thing I might want to do is now I want to write like application data. Say I don't just care about event data, I also care about like the calls that are happening behind the scenes and other things that's actually going on in my warehouse that's stuff that's not coming from an event stream, but maybe coming from data that's actually powering this application that I have. To be able to do that, it's super simple as well. So Stitch is one great way to do this. Again, there's a few other companies that can do this. So say I want to sign up. We'll do this as well with my kind of fake stuff here. So sign up. Get this password. Can password. So once I have this set up, now I just need to do this basically the same thing I did in Stitch, which is adding new integrations. And these will write things from say, like Intercom or from other application databases into Redshift. So the first thing I might want to do is set up Redshift. Well, it's actually going to ask me to do this stuff first. So let's set up Intercom. So I have Intercom on my site. To be able to set this up, I can just call this Intercom, and then just copy this little Intercom like app ID, which is right from the URL. And I save it, and then it'll spin for a second. Authorize it. And now it should be good to go. So now it's connected to Intercom. So Stitch is going to start pulling data out of Intercom. So every time somebody writes a conversation to Intercom, every time a new ticket, I'm actually going to start getting that written directly into my warehouse as well. The next thing I would need to do is set up the warehouse itself, which I can do here. AWS user. Not that. DC demo. Spelled that right. And so now it'll connect to the Redshift database, and now it handles all those pipes for me. And so what this means is, like all of these things, I've built these systems before these tools existed. It used to be something that took a long time to set up. It used to be something that like we had engineers maintaining ways just to sync data from like Salesforce into a database. And now in like a matter of a few minutes, you can actually set all this stuff up without like any engineering need whatsoever. It's something that I can all do like on my own without any help. And so now that data is being written into this Redshift database as well. So these pipelines are all live as well. They're things that Segment will write directly in without me having to change anything. Intercom will write things directly in without me having to change anything. All these things are set up and ready to go without me having to actually maintain anything anymore. The next step here, which I'm not going to actually bother with for the sake of time, is I could set up an integration from my Postgres database as well. It happens in exactly the same way. So if the internet here loads. You can also set up a Postgres integration using the same stuff. And so if I click on this, I'll just fill out these forms, and you'd be able to do the exact same thing. So you'd be able to have data from like a Postgres database, again, updating live to be able to start querying it in Redshift. The next step is how do you actually start working with this? So this is Mode. If I want to now sign up for Mode, I'll go through the same process. So if I just do this, come on. Come on. Come on. So, as soon as this happens, this is going to take me through like a sign-up flow to be able to connect the database. I'll fill out the same form again, and then I'm actually querying that database live. So again, all this in a matter of minutes, I can actually be like working off of live data coming from my website without ever having to like go through an engineer, without having to actually go through anything that doesn't take So the last part of this, so you can kind of see how this works, which I won't make you fill out this form one more time. You'll get what this looks like. You fill it out, and then you start writing queries against this live, starting to be able to build dashboards and charts and things like that. What this actually will look like as an end result, I have here as a sort of Julia Childing it in case time ran out. So you can build stuff like this. So this is on top of the data that would be flowing in. This is a live dashboard against that data. This is around that call thing. So if you were to look at stuff like the amount of calls that are coming in, the distribution of those call durations, the amount of time it takes to join, all this stuff is sitting directly on top of this same infrastructure, on top of a Redshift database that already has some of this data loaded in, because there's obviously not going to be a whole lot of events populated from this thing I set up 5 minutes ago. So the last bit is, say you want to actually build this transformation pipeline. So this is a place where DBT works really well. So DBT is you basically write SQL queries. Those SQL queries get populated in your database as views or tables, and it handles a lot of the pipelines and a lot of the how do you do the dependency management from that. If you can write these queries, say define it on another table, and then DBT will very much manage that dependencies for you. This is finally super simple to set up. So all you have to do to be able to do this is you run one command here. It will initialize this DBT repo. And then I need to open this up. And there will be a place. Oops. There will be a place where you fill out some database credentials here. Once you fill these out, then you can actually start building these models directly against your database. And so what this looks like is all you have to do, here's the simple model that it materializes for you. So this just got generated by that dbt init command. If I were to run this, it would actually run against that Redshift database, start populating these tables. And so I can actually define tables against those segment tables, against the intercom tables that I created, against other data in my warehouse, to be able to build out this much more robust modeling system and start baking in business logic into what I want to do as well. And so all that would take me to do is start writing these queries, and then there's some simple command line commands that you can run to do it. So I think with that, this was supposed to end at 11:30, and so that's the full extent of what you need to do. There's obviously much deeper you can go with this. I can show more things if people have questions, but you can actually do all this. Like I said, that was in 20 minutes. One of the things that's most notable about this stack is it's actually something that really scales. So we at Mode's like a 100-person company. This is minus Redshift instead of Snowflake, or Snowflake instead of Redshift. This is exactly what we use. This is everything that we use to be able to power the data science teams behind a 110-person company. And so rather than having to go out and hire an entire engineering team to build this, or even take weeks and weeks to spin this up, it's something that one person can sit down and do in 20 minutes. There's a few things like configurations you might want to deal with, obviously, I was doing all of this with a master user in AWS, or with Redshift. You don't want to do that. But outside of that, there's not anything else you need to do to be able to build something that scales with a company from 5 people to 200, 300. So with that, I can wrap things up. I have a question slide that doesn't really mean anything. But are there any questions?
Yes. How do those tools scale in the context of you just using a toy website, but some enterprise site that has 100,000 concurrents or something? Is there a place where they fall down? Or is there it's super expensive to use those tools? What happens at scale?
So they all scale really well. So Segment is used by a lot of if you go to their website, it's used by a bunch of major media companies, things like Fox and 20th Century Fox and folks like that get tons and tons of traffic. So those scale extremely well. Databases like Redshift and Snowflake, Snowflake is very much enterprise grade, so is Redshift. There will be times when cost becomes prohibitive there on the Redshift side, because Redshift doesn't separate storage from compute. So if you're storing sort of petabytes of event data, Redshift does become pretty expensive. But they have ways to actually move that data off into S3 using either Athena or something called Spectrum, which lets you kind of split the difference and kind of get Redshift on top of S3. So it's a pretty simple transition to go from one to the other. Mode scales well. So mode is basically querying the data where it lives in your infrastructure. So we don't actually have to worry that much about scale in that sense. Like the data processing scale mostly happens on your infrastructure, so it scales for us there. And Stitch is one place where there can be scale questions. So say you're wanting to replicate data from some like production database that's particularly huge. Stitch isn't necessarily going to be great for that. There are some other solutions there, but that's like getting into replicating on the order of tens of terabytes before you start to have a problem, which for most things that you're using like that size of data, it's like an event stream that you're not going to use it for anyway. Most like application databases or third-party like SaaS applications aren't scaling to that extent. So I don't know many folks who really run into scale problems. You run into scale problems if you're Netflix or Facebook or Google or whatever, but most of us aren't that. The last bit is in terms of cost. You do have to be aware, like there are some cost scales. So Segment, for instance, will get fairly expensive, though they have like lots. Once you get to that size, you can talk to them and they'll help out. All this stuff actually now is also running for free. This entire stack was actually set up on top of tools that you can initially use for free. So none of this actually would cost anything to do today. Yes?
How does Segment identify unique users versus sessions, or how do you take Segment data?
So they have like a cookie. So actually, if I go to Segment here, if this is still up, so they have this anonymous ID. So this is just a cookie from them. So if I were to like go back to that page in the same browser, if it was an incognito browser, they obviously can't. They also can tie into your own user ID. So say you're an application you log into, then you can pass that information to that, and that way you'd have awareness of it. So there's a lot of good stuff you can do there about like jumping the bridge between, say, a sign-up flow where they will have a consistent anonymous ID, which is this like Segment cookie throughout the sign-up flow, and then like a user ID will show up on inside of the sign-up flow where it wasn't showing up on the outside.
But if that cookie expires or you can figure it out, is there any way sort of?
No. I mean, you could add custom tracking to, like, you can add custom properties to these events. So say you wanted to add something custom, but people could clear your own cookies too. So it's sort of the same problem. Yeah.
I have a question about like org design. So if you're starting data and analytics and you want to spin up this stack, like, have you found with your users or clients, like eventually you're developing like, okay, you're using BigQuery and using all this ETL, but you don't want to use it and you have to do some sort of consolidation. How do you navigate that when you're, say, 6 months to a year in?
As in they don't want to use this many tools, or they have a different stack that they want to integrate with?
Second.
So most of these tools integrate fairly well with the major players across the ecosystem. So things like Snowflake, BigQuery, Redshift, Postgres, if you're using that as a warehouse, which some people do. Spark, in some cases, people are using them for this. Most of these tools integrate pretty well with those. So they kind of mix and match across like the major things. Segment works well with those. Stitch and Fivetran can write to all those things. Mode can connect to all those. Every once in a while, you'll run into people who, like, probably the most common thing is, we're a Mongo shop for some reason. What do we do there? There are some ways to be able to handle that. In most cases, what we encourage folks to do is try to move into this ecosystem, because everything is getting built around it. So if you're like using Mongo, what the problem is, not only do you have to deal with like the occasional problems with using Mongo, you have to deal with nothing else is going to get built for you. These tools don't exist for you, and neither will future tools. So there are people who are like working on helping do those translations, but for the most part, if you run into that, it's kind of helping migrate to these future things. The other version of that is like the very enterprise version of, we are on some like SQL Server from 2008. And in those cases, there's just kind of, you have to modernize to some degree. Like most of these modern tools are not going to get built for legacy versions of SQL Server or some Oracle thing that hasn't been updated in a decade.